Hi guys, this is Kyle Tierney again. This is our second video in the Common Core Geometry Review series, and today we're going to be continuing our discussion about lines and angles. There are really three important things that happen in every man's life. The first would have to be moving out of your parents' house. The second would be buying your own car, and the third would be learning about supplementary angles. Of course, I'm joking, maybe, but I do need to explain to you guys some important things about supplementary angles, and supplementary angles are not very hard to understand. Supplementary angles are simply angles that add up to 180 degrees. So for example, I may have one angle that looks like this, and that may be 120 degrees, and then I may have a second angle that looks like this, and that may give me 60 degrees. But both of them together add up to 180 degrees. And you may remember from our previous lecture series that 180 degrees is also the measure of a straight angle, also known as a line. So supplementary angles add up together to give me a line. And now I drew in this particular scenario right here two angles that are adjacent to each other. That means that they're touching each other. But that doesn't always have to be the case for angles to be supplementary. For example, I may have one angle over here that's 120 degrees, and I may have a second angle all the way over here that's 60 degrees. It doesn't matter if they're touching, they still add up to be 180 degrees, and thus these two angles are supplementary to each other. Now let's try a quick practice problem. Let's say that I have a setup like this. I've got a straight line, and I have this strange line right here, line BC, or rather that's actually a ray BC, coming off from the middle of the line. And so originally I had a straight line, but now I've split up my line into two different angles, or two different parts. What I'm going to tell you is that angle DBC equals 140 degrees. What I want you to find for me is what is the measure of angle ABC. And if you're confused about what this little M thing right here is, M simply means measure of in geometry. So this whole thing right here is shorthand for measure of angle ABC. Pause the video real quick and see if you can figure out how to solve this on your own. Okay, so the first thing that I need to do here is I need to identify where angle DBC is, because I know that angle DBC adds up to 140 degrees, so that needs to be my starting point. We're going to start on point D, we're going to go to B, and we're going to end on C. The second thing that I need to do is I need to identify where angle ABC is, because that's my unknown. It's what I'm looking to solve for. So I start on A, I go to B, and I end up at C. So this is angle ABC. And I'm not sure what that measure is yet, but I'm going to find it out. So as you can see though, from what we've been talking about, these two angles, DBC and ABC, both create a straight line or a straight angle. So we know that angle DBC and angle ABC are going to be supplementary to each other, which means that they have to add up to be 180 degrees. So I'm going to start us off with a little bit of an equation here. I know that angle DBC, that's this guy right here, and angle ABC, that's this guy right here, have to add up to give me 180 degrees. And the reason is because when you put them both together, they give me a straight line or a straight angle, which gives me a total measure of 180 degrees. And we know that these two angles are going to be supplementary to each other in that case. So what I can say is that angle DBC plus angle ABC has to give me a total measure of 180 degrees. Now I know that the measure of angle DBC is going to give me 140 degrees. That's my known, and so I can substitute that into my equation down here. I still don't know what the measure of angle ABC is yet, and that's what I'm trying to solve for, so I can just leave that the same in my equation. And just like before, I know that both of these angles have to add up to give me 180 degrees still. So what I'm going to do is I'm going to subtract 140 from both sides of my equation, and you'll notice that on the left side of my equation, the 140 is going to subtract 140, and so my 140s are going to cancel each other. What I'm left with on the right side of my equation is just 40 degrees, because 180 minus 140 is equal to 40 degrees. And all I have left on the left side of my equation now is just angle ABC. So I can definitively say that angle ABC is equal to 40 degrees. Simple. Now let's try a harder practice problem. Now just like before, I'm going to give you a straight line, but this time instead of giving you one ray coming off of the middle of the line, I'm going to give you two rays coming off of the middle of the line, BC and DB. Now what I'm going to tell you is that the measure of angle DBE equals 50 degrees, and that the measure of angle ABC equals 60 degrees. And what I want you to find, the big question here, is how much is the measure of angle CBD? Pull out a sheet of paper, pause the video, and try it on your own and see if you can solve it. Okay, so first let's identify where angle DBE is. And that's right here. Angle DBE is this blue line that I'm drawing right here. And so we know that that is going to give us an angle measure of 50 degrees. So I'll draw a 50 right there. The next thing that I need to do is I need to figure out where angle ABC is, and that happens to be right here. We're going from A to B to C. And I know from right here that angle ABC measures 60 degrees. And lastly, what I need to do is I need to find where angle CBD is. Well, that's right here. It's from C to B to D. And the problem is that we don't know how much that angle measures, but we're trying to find it. And the first thing here that should jump out to you guys is that when I add up all of these angles together, I'm going to get a straight angle or a straight line. That's going to give me a total measure of 180 degrees. So I know that when I add up all of these angles together, they have to equal 180 degrees. And they're all going to be supplementary to each other. So I'm going to write a little bit of an equation for you guys. So we know that the measure of angle DBE plus the measure of the angle ABC plus the measure of angle CBD all have to add up together to give me 180 degrees because they make a straight line. The next thing that I can see here is that I know the values of DBE and of ABC. So what I need to do is I need to substitute those values into my equation. And so I know that DBE is equal to 50 degrees, and I know that ABC is equal to 60 degrees. I still don't know what the measure of angle CBD is yet, so I'm going to leave that the same. And I know that they all still have to add up to give me 180 degrees, so I'm going to leave that the same as well. Now, a quick thing that I can do here to assess this is that adding up 50 to 60 is pretty easy. I know that that's going to give me 110 degrees, so I can write that down. And just like before, I still don't know what my measure of angle CBD is yet. And I know that together they still have to add up to give me 180 degrees. So what I'm going to do is I'm going to subtract 110 degrees from both sides of my equation. So minus 110 on the left and minus 110 on the right. And you can see that on the left, both my 110 degrees are going to cancel each other. And 180 degrees minus 110 degrees is going to give me 70 degrees. So I can say that the measure of angle CBD equals 70 degrees. Cool stuff. And now the next thing that I want to talk to you guys about is a slight twist on what we've learned so far. Supplementary angles add up to give me 180 degrees, but sometimes I have angles that add up to give me 90 degrees, and we call those complementary angles. Now, in case you guys forgot, 90 degrees also happens to be the measure of a right angle. So anytime we have complementary angles, we have two angles that not only add up to give us 90 degrees, we have angles that add up together to give us a right angle. And so this right here is a right angle that I've drawn for you already. But what we might have with a complementary angle is we might have some ray coming off like this. And notice now that it split up my nice, neat right angle into two ugly partial angles that look like this. And these angles are going to have some measure less than 90 degrees separately. So for example, this angle might measure 60 degrees, and this angle might measure 30 degrees. But notice that together, 60 degrees plus 30 degrees is going to give me a total angle measure of 90 degrees because they're complementary. So let's do a quick practice problem. Let's say that I have an angle like this, and it's a right angle. And let's say that all of a sudden I have a ray come out of it, and it looks like this. I've got to label my lines and my rays. So let's say that this point right here is B, this is A, and this is C, and this is D. Now I'm going to tell you that the measure of angle DBC is equal to 40 degrees. What I want to know is how much is the measure of angle ABC. Pause the video real quick and see if you can figure this out on your own. So the first thing that we need to do here is we need to identify where angle DBC is, because we know that angle DBC is equal to 40 degrees, so we should start with what we know. And angle DBC is this angle right here. We start at D, we go to B, and we end at C. And so we know that angle DBC is equal to 40 degrees. The next thing that we need to do is we need to find out where angle ABC is. So what we're going to do is we're going to start at A, go to B, and end at C. And as you can see, that's going to give me this angle right here. And we know that this is what we're looking for. We're not sure what that measures yet. But what we do know from the beginning is that this entire setup right here, when I add both of these two angles together, it's going to give me 90 total degrees. because it's a right angle. And so we can say that angle ABC and angle DBC are complementary to each other. Now, since I know that angle DBC and ABC are complementary to each other, I can write an equation. I can say that the measure of angle DBC plus the measure of angle ABC have to equal a total of 90 degrees. Now the next thing that I need to do is I need to substitute my known values into this equation. And I know that the measure of angle DBC is equal to 40 degrees. So I'm going to substitute that into my equation first. So DBC is 40 degrees. I still don't know what the measure of angle ABC is yet, so I'm going to leave that the same. And I know that they both still have to add up to give me a total of 90 degrees, so I'm going to leave that the same. And now what I need to do is I need to isolate that measure of angle ABC on this left side of my equation, because that's what I'm looking to solve for. So what I'm going to do is I'm going to subtract 40 from both sides of this equation. And I can see that on the left, my 40 degrees is going to cancel. And on the right, if you guys remember correctly, you can see that so now what I'm going to do is I'm going to subtract 40 from both sides of my equation. So subtract 40 from the left side of my equation and subtract 40 from the right side of my equation. And now 90 minus 40 is equal to 50 degrees. So I can say that the measure of angle ABC is equal to 50 degrees. Nice job. Now I'm going to give you a little bit of a harder practice problem to work on. So I'm going to start you off with another 90-degree angle, or in other terms, another right angle, but I'm going to delete that little box that signifies it's a 90-degree angle to make space for my other drawings. And now, instead of last time where I only had one ray coming off of the vertex of my right angle, I'm going to give you two rays coming out of the vertex of my right angle. And so now I'm going to draw my little angle marks right here. And there's a shorthand way of showing the names of angles. And sometimes the way that we name angles is what you're used to, what I've been showing you, where we say angle ABC. And that's all well and good, but sometimes we have a lot of angles in a tight space. So a really quick shorthand way that maybe isn't totally mathematically correct, but gets the job done is we simply write this as angle 1, angle 2, and angle 3. And that's what I'm going to do here, since our angles are kind of in a tight space and it would just be kind of messy to draw everything out. So let's say that I have three angles created now, angle 1, angle 2, and angle 3. I'm going to tell you that the measure of angle 1 is equal to 25 degrees. And I'm going to tell you also that the measure of angle 3 is equal to 26.5 degrees. What I want you to do is I want you to find what the measure of angle 2 is. I'm not going to tell you. Pause the video real quick and see if you can figure that out on your own. So the first thing that I'm going to do is I'm going to identify where my angles are. So angle 1 is right here, and I said that that is equal to 25 degrees. That is angle 1. Angle 3 is the other angle that I know, and that's equal to 26.5 degrees. So angle 3 is right here, and that's equal to 26.5 degrees. I'm not really sure what angle 2 is equal to yet, but angle 2 is right here, so I'm going to put a little question mark right there. And what I'm going to do is I'm going to write out an equation I know that all of these angles have to add up together to give me a total of 90 degrees because they make a right angle, and right angles always equal 90 degrees. We can say that angles 1, 2, and 3 are complementary angles since they add up to be 90 degrees together. So let's write out our equation. I can start off by saying the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is going to add up to give me a total of 90 degrees. Now the next thing that I need to do here is I need to substitute my known values in for my variables in this equation. I know that the measure of angle 1 is equal to 25 degrees, so I'm going to substitute 25 degrees in for angle 1. I'm still not entirely sure what the measure of angle 2 is yet, so I'm going to leave that just as it was and simply leave it as measure of angle 2. Now I also know that the measure of angle 3 is 26.5 degrees, so I'm going to substitute in 26.5 degrees there, and still just like before, all three angles have to add up together to give me a total of 90 degrees. So I'm going to sub in 90 degrees right here. Additionally, what I need to do now is I need to somehow simplify this equation a little bit because I have a lot of numbers floating around here. So I'm going to add together 25 degrees and 26 degrees. And actually 26.5 plus 25 is equal to 51.5 degrees. So what I'm going to do here is I'm going to write down 51.5 degrees plus the measure of angle 2, and it still has to add up to equal 90 degrees, so I'm going to write down 90 degrees right there. The next thing that I need to do is I need to isolate my angle 2 variable on the left side of my equation, since that's what I'm looking to solve for. So what I'll do is I'll subtract 51.5 from the left side of my equation, and I also have to do the same thing to the right side of my equation. So I'll subtract 51.5 from both sides of my equation, and on the left side you can see that 51.5 is easily going to cancel and give me 0. And on the right side of my equation, 90 minus 51.5 happens to be 38.5 degrees. So I can see that the measure of angle 2 is going to be 38.5 degrees. And now my problem's solved. Nice job. Now the last thing that I want to introduce you guys to is just a little caveat. It's nothing major. We've been having these scenarios where, for example, we've had a right angle and it's just a regular right angle like that, and then all of a sudden we draw a ray in the middle, and then that splits up our right angle into two separate angles. And one angle might be equal to 40 degrees, and then my second angle might be equal to 50 degrees. And that's all well and good. It splits up my right angle into two angles. They both add up to be 90 degrees. Everything's copacetic. We're good. But sometimes what you see is that when I draw a ray, it actually splits it up into two equal angles, so that I don't get, for example, 40 and 50 degrees. I'll get 45 degrees and 45 degrees. And it doesn't always have to happen with a right angle. For example, I may have an obtuse angle, and maybe my obtuse angle has a total measure of 120 degrees. But then I draw a ray coming out of the vertex here, and what can happen is, even though my total measure of my obtuse angle is 120 degrees, I can get 60 degrees here, and I can get 60 degrees here. Both of these angles that I've created from my ray that I added are equal to each other, and they both add up to be a total of 120 degrees. When this happens, when we have a line that comes in and it splits up an existing angle and it creates two new angles that are exactly the same, we call this an angle bisector. Okay, so I want to thank you guys for tuning in to this week. And next week, what we're going to do is we're going to cover some more advanced line and angle theorems, and we're really going to dive into this chapter and get into the meat of this unit. So I hope that this hasn't been overly confusing or too easy for you. If there is anything that you're confused on, please make sure you leave a comment in the comment section, and I can do my best to answer your questions. And please don't forget to subscribe, and feel free to tune in next week. Thanks.